All right, for the first part of this lesson, we're going to solve some quadratic equations by using the quadratic formula. And then we're going to talk about the related function to this. So I'll help you get started with the first one, and then you can probably do the last two on your own and then check your work. So the first thing I need to do is rearrange this so that I have 0 on one side of the equal sign. So we're going to have 3x squared plus 8x, and then we'll have a minus 4 equals 0. All right, so we're going to use the quadratic formula. The a value is the coefficient of the x squared, the b is the coefficient of x, and the c is the constant term. And then we are going to solve and say x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, so simplifying that, we're going to have our negative 8 plus or minus 64 plus 64. Get my calculator going so I don't make a mistake here. I got 112 out of that. 112, and then divided by 6 here. So our two values of x would be negative 8 plus whatever the square root of 112 is, and then take that answer and divide by 6, or x will equal negative 8 minus the square root of 112 divided by 6. And throw that into the calculator. I'm going to just take that to 2 decimal places. I get 0.43 approximately here for that one. And then the other one, I get negative 3.010. When I round that carefully, 3.10. All right, so the graph, the quadratic function, the related quadratic function looks like this. The related quadratic function would be y. Instead of the 0, we're going to have y equals 3x squared plus 8x minus 4. From standard form, I know this parabola should open up and have a y-intercept of negative 4. I also have my x-intercepts. So if I just do a little sketch of this, we're going to have x here and y here. We have our zeros at that and that opening up. So my parabola could look something like this. Okay, where this value here, this one x-intercept, would be negative 3.10. This x-intercept would be 0.43. And my y-intercept here would be at negative 4. Okay, so that's what we have right there, graphing the related function. So try that with the next two examples that you can see here on the handout or on that page, and then you can check your work with those. All right, for part B here, I rearranged and then used my quadratic formula. The kind of cool thing with this one is that we ended up with a 0 under the square root sign. So this b squared minus 4ac had a value of 0 here, which resulted in just one actual x-intercept. I got my two answers here, but my two answers are the same answer. So there's only one x-intercept. If we think of a graph where a parabola can only have one x-intercept, it means that vertex is right on the x-axis there. And this parabola is opening up, if I look at that, and the y-intercept is at positive 2, and that makes sense when I draw the parabola like that. So this value is a 1, and this is a positive 2 right there. That's what we know about that parabola. So the under the square root sign, when it is 0, we end up with one x-intercept. Try part C if you haven't done so already. I'm going to move ahead and do that. Okay, I've rearranged my equation. I got 3x squared minus 4x plus 5 equals 0. I put that into the quadratic formula. And I want to draw your attention to, again, that part under the square root sign here. Under the square root sign, I ended up with negative 44. If I have negative 44 on my calculator and I try to square root that, I get an error on my calculator. You cannot square root a negative number. So there's no solution to this, which in terms of what this means, in terms of our parabola here, if we look at this parabola, it is opening up Now, remember, by solving, you're really finding the x-intercepts of that parabola. What this means is that there's no solution to the quadratic equation. That means there are no x-intercepts when we go to graph this. So you could actually throw this equation into Desmos and see what it looks like. I do know it has a y-intercept at 5 and it's opening up and fairly skinny, but other than that, I got nothing. There are no y-intercepts, or sorry, x-intercepts here. There's a y-intercept, but no x-intercepts. So let's see what's happening with Desmos. I'm going to just throw it into my Desmos, but I'm putting this on pause for a moment. So I was able to just check what that parabola actually looks like when I put it into Desmos. It is opening up. It is fairly skinny, and it looks something like this with the vertex slightly to the right of the y-axis. So all we have based on the equation is this information here. So when you have that value under the square root sign being a negative, there are no solutions. There's no x-intercepts for that parabola. If it happens to be equal to 0, like it was in part B, it means there's one x-intercept for your parabola. And if it happens to be a positive number under that square root sign, then there's going to always be two answers. You're going to get it with the plus the square root and the minus the square root there. So from here, we're just going to summarize that information, and then we will, actually I'll do that on a new slide here. We'll summarize the information on the discriminant, and then we'll do a couple of quick examples here. All right, so the discriminant is the part of the quadratic formula under the square root sign. Your discriminant is that b squared minus 4ac piece of the quadratic formula. If that b squared minus 4ac is positive or greater than 0, there will be two solutions or two x-intercepts for your parabola. If b squared minus 4ac is equal to 0, like part B, then there's going to be one solution or one x-intercept. And if b squared minus 4ac is negative, less than 0, that gives you no solutions, no x-intercept. There's no value of x that will make that quadratic equation true. All right, so let's do an example or two here just to help us out. All right, and with the magic of technology, I have my question without solving how many zeros does each parabola have. So I want to know what that value of the discriminant actually is equal to. So my A is 2, my B is -4, and my C is equal to 3 here. I'm just going to check the value of b squared minus 4ac. We just want to see what that's equal to. So -4 is my b squared minus 4 times 2 times 3. That's going to give me 16 minus 4 times 2 is 8 times 3 is 24. That's going to give me -8. And I said 24 and I wrote 25. My brain is sequential apparently. That's maybe good, I don't know. Okay, so because this is less than 0, so this is less than 0, so therefore this parabola will have no x-intercepts. All right, so again, we can try that with this one. A equals -1/2, B equals 8, and C equals -1. We're going to check the value of b squared minus 4ac. B is 8 squared minus 4 times -1/2 times -1. That's a 1. That's going to give me 64 minus 1/2 of 4 is 2. 64 minus 2 is 62. So 62 is positive, that's greater than 0, so there will be two x-intercepts. All right, let's try another example here. All right, I've given you a part C here just because. You'll notice that this is not in its standard form. Now I could expand and simplify and put it in its standard form, but I'm going to use my mathy senses here. This is vertex form. From here, we know that the vertex, let's get the right color out here, the vertex is at, switch the sign on the x, -3, comma 2, and this parabola is opening up. So if I think of what this looks like, -3, +2, -3, +2 would be right about there, and it's opening up. Ooh, just from a picture right there, this has no x-intercepts. So be smart about the format that you've been given. to see what makes sense in terms of x-intercepts. Standard form, yeah, check your b squared minus 4ac. If you've got factored form, automatically you have 1 or 2 x-intercepts, because as long as you can factor it, those factors give you what the x-intercepts are. If it can't be factored, then there would be no x-intercepts. But if you have vertex form, check where the vertex is and the direction of opening, and just do a quick sketch, and that will help you figure out how many zeros the parabola has. All right, and I have one more example I would like to do with you. All right, for what values of k will this equation have 1 solution, 2 solutions, or no solution? Okay, to have 1 solution, we know that b squared minus 4ac has to equal 0. And if I look at the equation, my a is 5, my b is k, and I meant to make that a plus k in there. It doesn't really matter, but change that to a plus there, plus k. My b is k, and my c is 5. So my b will be k squared minus 4 times 5 times 5, okay, has to equal 0. Not a very creative example on my part. This is going to give me 25 times 4 is 100. Now I'm going to isolate for k because I don't have other k's to worry about. I've got a single k except it's squared. I'm going to square root both sides, and when we do, we get 2 answers. So if k was positive 10 or negative 10, this will have exactly 1 solution. Okay? Now for the second part, to have 2 solutions, this b squared minus 4ac has to be greater than 0. Has to be greater than 0, which then means when I have my k squared minus 100, that has to be greater than 0. Okay, I've already done my b squared minus 4ac right here, so I'm just using this information to help me out with here. Okay, so I want that to be greater than 0. So that means my k, my 2 values that I got in part A were positive 10 and negative 10. If my k was bigger than positive 10, positive 10 squared gives me 100, 100, take away 100 gave me 0. If I go to 11, for example, 11 squared would be 121. 121 minus 100 would give me an answer bigger than 0. Or if I took a value of k that was less than negative 10, like negative 11, negative 11 squared would give me 121, which would keep that discriminant greater than 0. Now, having said that, we've done the 2 easier parts. The harder part, although now it's easy since we've done the first 2 parts, at 10 or negative 10, we have exactly 1 solution. When we're bigger than 10 or less than negative 10, we had 2 solutions. If our k is between negative 10 and positive 10, we're going to end up with a value in here where we will get an answer that's less than 0. So let's say we had k being equal to 9. 9 squared is 81. 81 take away 100. So let's just talk about that. 9 squared take away 100 would end up being a negative value. Will be ending to be a less than 0 answer. Likewise, if you picked a value that's negative, but between negative 10 and positive 10, negative 5 squared would be 25. Minus 100 would give you minus 75, which is less than 0. So you can do a little check to see if that works. But that's how you can answer that question.